Reaction kinetics, okay, we are going to look into two types of graph. Okay, the graphs that we are going to look at, there are two, which is going to be, one is the basic one, which is going to be concentration. So this one is concentration against time graph. Okay, this is concentration against time. And we also have another graph that we need to take note. Okay, this one is going to be rate against concentration. Okay, so we need to actually know about these two graphs. Okay, so I will write down like this. Now, so if it is going to be, we have three types of graph. Okay, one, okay, we are taking into consideration, like for example, this is a graph of reactants, for example. So for the graph of reactants, we know that, okay, one, okay, the reactant can decrease over time. Okay, so this is going to be one of it. We also have another type, okay, also decrease, but with a different, I think there are two types of decrease, yeah, curve. Okay, so there is going to be two types, and then we also have one more type, which is going to be, they will decrease maybe from here. So I'll just put it over here. Okay, they will decrease in that way. So definitely there is no negative. So up to here. Okay, so if I actually put it down, okay, which one is which? Okay, so always remember, okay, if the blue one, this one is going to be known as zero order reaction. Okay, zero order reaction. And okay, the thing that you need to take note over here is when you find out the gradient. Okay, the gradient, because it's going to be a straight line, the gradient, there is a constant gradient. Okay, so the gradient is actually the K. Okay, because you can actually see the triangle is still going to be the same triangle. But for these two reactions, okay, for these two graphs, okay, the gradient are different. And I heard about when you did your discussion yesterday, you mentioned about the gradient are changing. Of course, they are changing. Okay, you can see at any reaction at the beginning, this is going to be a very fast reaction at the beginning. Okay, but after that, over some time, okay, the gradient will decrease. That's why you can see that, okay, the triangle, if you keep on drawing triangle for the gradient for the two graphs, the yellow line and the green line, the gradient will decrease over time. Okay, so it will become more flatter and flatter. Okay, so the gradient is going to be decreasing depending on few factors. Okay, the factors will be, if let's say this one is going to be reactant is being used up. Okay, so when the reactants are being used up, the concentration of the reactants are less. So if you have less concentration, rate of reaction also will become lesser. So that is going to be, if you want to refer back to your concept of rate of reaction. Okay, but anyway, do remember, the steeper the graph, that is going to be the second order, and this one is going to be first order. Okay, first order. But the important thing is when you draw the rate, okay, just now I told you the blue line, okay, it's going to be a constant gradient. So if you are talking about constant gradient, the blue line, okay, if you want to draw, it is not affected by any change of concentration. So this is going to be for zero order. Okay, zero order. And if it is going to be the yellow line, okay, the yellow curve is second order. If it is second order, okay, this is going to be following, okay, this quadratic curve. Okay, this is going to be second order. And this first order reaction, okay, the first order reaction is going to be a straight line graph. Okay, so if I change over here, so there will be something like this. This is going to be first order. So please do remember, these are the graphs that we need to actually focus on, okay, when it comes to your reaction kinetics. So this is graph, And we are going to refer to order of the reaction based on the graph as well, because the graph will also tell us some details about the order of the reaction. But do remember, okay, whenever we have rate equation, the rate equation is normally written in this format. So rate equation, rate equals to K, and then they put something like this. So I just put generically A, B, and then M and N. Now, what does it mean? K is going to be the rate constant. So the rate constant is going to be, if you are looking at your zero order reaction, the K is the gradient. Gradient of what? The gradient of the concentration against time graph. Yeah. So these A and B, they can be the reactant, but not necessarily must actually take all the reactants. Some of the reactants will not be there, because this concentration of A and B, whether they are going to be here or not, it is going to be determined not by the equation. They are going to be determined by the experimental data. So you need to refer to the experimental data. You plot the graph like this, you plot the graph like this, then they will actually tell, oh, you need to put it there. Okay, so if it is like zero order, okay, zero order, okay, you are not going to have any value for the n equals to 0 or m equals to 0, for example. Okay, so please take note of that. And the value of m and n, okay, the m and n is not referring to the stoichiometric equation, okay, or the value that you have in front of the equation. It is also determined by, okay, again, like what I said, it is determined by the experimental data. So you need to refer to that. Yeah. So that is going to be m and n. But do remember, this rate constant, okay, this rate constant is affected, okay, is affected by other factors. Okay, it is affected, that that's why you need to actually be careful when you do this experiment. The experiment is done under standard condition. Okay, so normally we do it at 25 degrees Celsius at certain pressure, because K, okay, the rate constant is dependent on the temperature. Okay, they are dependent on the temperature. So we will actually leave it over there. It's actually dependent on the temperature. But if you need to know also, okay, how to actually calculate or how to come up with the unit of the K. Yeah. So do remember, the rate in our syllabus is going to be concentration divided by time. So the unit here is mole per dm cube per time. Okay. So whatever value or whatever rate equation that they give, okay, if they ask you to calculate the unit of K, you should be able to calculate the unit of K. Yeah, please do that. And then what else we need to take note? I think that's all. Okay, I think that's all. I think there is also some question they will ask you about the overall order of the reaction. Now, the overall order of reaction depends on, just if you have something like this, so the overall order of the reaction is m plus n, something like that. Okay, so that is going to be the overall order of the reaction. So you just calculate, okay, the m plus n. Okay, then that's going to be the answer, overall order. Okay.